Let's go ahead and get started this morning. This is our first briefing of the day. This will be a single subject briefing. This morning we have Colonel George Sditac, who comes to us today from Fort Sill, Oklahoma, which is the Army's Field Artillery Center and School, where he is currently the TRADOC Systems Manager for MLRS and ATACMS. Colonel Sditac has 25 years of experience in the artillery. He's commanded both cannon and missile artillery units and served in a variety of fire support assignments. He's going to have a short briefing, and then he's going to be here to answer your questions. Colonel Sditac.
Good morning. In case you haven't seen the name Sditac before, it's not a common one. Recommended that I spell it. S-V-I-T-A-K. Right. Now that I see everybody's got that copy down. Before I get to the chart specifically, what I'd first like to do is just give you an overview of the MLRS system and some of its capabilities. The MLRS system was first fielded in the Army in 1983, and it first saw combat action during the Gulf War. If you recall from some of the footage coming out of the Gulf War, you saw the units forward with the Abrams tanks as well as the Bradley fighting vehicles. So it's a direct combat system. And a direct combat system that provides the Army not only lethal rocket fire, but also a deep strike capability through the ATACMS missile capability. If you take a look at the system itself, and that's where it's earned its nickname. It's called Steel Rain by the Iraqi prisoners, based on the lethality and the devastation that they witnessed and experienced as part of the ATACMS and MLRS system. What I'd like to do is talk about how we're organized, just to give you an overview, and then at the end I'll go down and talk about the specific capabilities of not only the launcher, but we can talk about the rockets and the missiles themselves. The way the ATACMS units are organized, they're organized in Army battalion-sized units, but they have a specific mission depending on where those units are located at. We are organized to support corps-sized units, so there are MLRS battalions that are assigned to Army corps, and then there are also MLRS battalions that are assigned to Army divisional units. What I'll point out at this time, they are the same launchers that possess the same capability. So whether assigned at the Army Corps level or at the Army divisional level, they have the same capabilities. It's how they're employed that varies, and it's changed a little bit, and we could talk about that as we go on. So that's the basic organization. The average size unit is about 394 people. Based on force structure, we have reorganized MLRS battalions into 3 batteries each of 6 launchers, as well as a headquarters and then a maintenance element. That's pretty much the manning, the organization, and how we employ it. If you take a look at it, just like other systems, it can be a tailored force. In other words, you don't have to employ the entire battalion at one time to utilize its capabilities. You can deploy as small as a 3-launcher platoon element. That brings with it the command and control, and the command and control that allows it to integrate into communications as well as fire control systems that go up to the Corps and Theater Army level. MLRS has the capability, and we routinely train on an integration with our joint services. So we do joint combined arms exercises, joint combined arms training. So in a situation where we deploy as a JTF, such as we have now in Albania, that it's easy to integrate this capability into the force because we routinely train with that. And that's how we go through it. So from organization, can support a corps, can go down to the divisional unit, can deploy as small as 3-launcher platoon, can deploy as multiple brigades or battalions in support of the core force. At this time, I'll start talking about the capabilities, and I'll start with the M270 Launcher. As I said, the system was fielded in 1983, and this is the basic launcher that came out. Here a picture showing firing a rocket. While I won't go through the system description, I will talk a little bit about it. The system itself survives based on its mobility. It can keep pace with the M1 and M2, so in other words, the Abrams tanks and the Bradley fighting vehicles. This system is designed to keep pace with our maneuver forces. Matter of fact, the chassis itself is a Bradley chassis. What we've adapted from that Bradley chassis is what we call the loader launcher module. This loader launcher module can carry up to 2 pods of 6 rockets each for a total of 12 rockets, or it can carry 2 ATACMS missiles. The way the individual pods are designed, and from the exterior, you can't tell whether it's carrying rockets or missiles. So again, survivability, mobility on the battlefield, all lends in how of our tactics, techniques, and procedures of how we operate in the field. As you see, it has a 3-man crew. The 3-man crew, they live and fight from the cab of that vehicle. You have a driver, you have what we call a gunner, a good field artillery term, who actually runs the fire control computer on board the MLRS platform. And then you have a chief of section. It's supposed to be an E5 or E6, and that's the way we man it out. So ideally, a 3-man section that fights that vehicle. The key thing to note about the MLRS system and how it's employed, it's an all-weather capable 24-hour-a-day system. So when we train, we work full ops, rotate platforms, keep the full up capability regardless of weather, 24 hours a day. If you take a look at the performance capabilities, the combat radius is equal to that of our other combat maneuver fighting systems. Say 300 miles, the speed comparable to Bradley's as well as M1 tanks, but the capability that changes as we go down into the different munitions that the system is capable of firing. The only thing I'll talk about finally on the launcher itself is that its communication systems. It has the communication systems for both analog voice as well as digital communications. If you take an evolution of how our communication systems are going, digital transmissions to other platforms that are out there within the joint services. So we have the connectivity that allows the command and control down through launcher execution, and that's pretty much how we work our operational missions. Next slide, please. First thing I'll talk about is the capabilities that were fielded with the launcher in 1983. And I'll start off with what we call the basic MLRS rocket. If you get into nomenclature, it's called an M26. And talk about the range. It may be hard to see in the back, but roughly 32 kilometers. Payload, it carries a dual-purpose, improved conventional munition as the submunition. It carries 644 of those. Ballistic, free-flight rocket. One of the things we noticed during the Gulf War is that we were often outranged by enemy systems, not only their rocket systems, but also their cannon systems. So while we showed the basic M26 rocket that was fielded and was fired quite extensively during the war, we found there was a need for an extended range capability. As a result of that, we're in the process of now fielding what's called the extended range MLRS. It goes from a range of 32 kilometers out to a range of 45 kilometers. Excuse me?
Is that operational now?
Yes, it is. And again, it's a ballistic free flight rocket. If you take a look at the target set that this rocket would be used against, rockets are traditionally associated with divisional type support. Shorter range in support of a division maneuver area to engage counter-fire targets. So we talk about counter-battery, logistics, command and control sites that would normally be within an enemy's divisional size sector or enemy regimental sector. Purpose of rockets really to supply the close supporting counterfires within a divisional organization.
Excuse me, can I stop just briefly
Sure.
while you're there? Since those are free flight rockets. What's the accuracy within so-and-so, since they're free flight?
A single rocket, and this is unclassified, is about 300 square yards is its effectiveness, and the accuracy, that I can't get into in specific detail. But it's accurate enough to engage the area type targets that it was designed for. We have a target location, you put it into the computer, and based on a free flight system, the accuracy is there to achieve the desired effects.
Well, by 300 yards, you mean
Single rocket, I'm talking
hit
the
an area of 300
warhead
square
event.
yards.
Right.
But you can't be sure where it will hit within that area. That's the accuracy.
Well, like I said, it's not a precision-guided munition. It's an area-fire weapon. And again, if you take, there are ballistic formulas that tell you how accurate the system can be based on range, based on winds and everything else, and that's what's accounted for in the ballistic computer when we compute where the target area grid is.
Colonel, so if you were to aim this at home plate at Memorial Stadium in Baltimore, which was perhaps 45 kilometers, you would strike home plate, or you would strike the entire infield, or you would strike the entire stadium?
We would, now, one rocket or multiple rockets?
We'll say one rocket.
Okay.
Well,
We would strike the stadium. remember that field artillery is designed to be, this particular system is an area fire weapon. When we design the system, when we fielded the system, if you take a look at a fielded enemy force, and we'll use the Iraqi force there, you're shooting at target areas, say a counter battery or a D-30 howitzer that may cover 400 by 500 square meters. This is the type of system that the MLRS rocket was designed to engage and take out. Same with their command and control, or their radar systems, dispersed over a larger area, and in that have a command and control node, as well as the radars themselves and air defense systems, area fire system for the rockets. The other system that was first employed during the Gulf War was the ATACMS Block 1 missile. Again, when you think ATACMS, you think deeper strike, greater capability that it provides the Corps commander. Deep strike, in this case, out to a range of 165 kilometers, approximately 100 miles. Again, not free flight. The big difference here is the inertial guidance. It uses a ring laser gyro, multiple ring laser gyros that provide the inertial guidance that it receives from the firing platform itself. If you take a look at the target sets, and I won't go through and read them, but again, it is an area fire weapon, but with a greatly extended range and a greatly extended lethality. And the lethality changes, and I'll talk about that because when you take a look at the submunition that it contains in the Block 1 missile. Block 1 missile is what we call the M74 bomblet. It's not dual-purpose ICM, as in the rocket. This is an anti-personnel, anti-material submunition. So it has an explosive burst capability, and actually the casing itself is made of titanium that bursts into multiple fragments, as well as what we call a pyrophoric pellet that can also start fires in ammunition, fuel sites, etc. So if you take a look at the capability of the submunition, and you take a look at the target set, you can see how we kind of look at what we are asking our munitions to be able to achieve. Matter of fact, there were 32 ATACMS that were fired during the course of the Gulf War. And again, because of that deep strike capability, 24 hours a day, totally weather independent, it was a very useful tool for the Joint Force Commander. The only comment we had coming out of the Gulf War referenced the ATACMS system, which was fielded and fired for the first time there, is that the Corps Commander and then the Joint Force Commander said, we sure would like to have something with a little bit greater range and something with a little bit greater accuracy. If you take a look at the nature of targeting and where we're going from, large fielded enemy force, dispersed over a wide area, and artillery is an area fire weapon. Now we see the rules of the game are changing a bit. We're going to more precision, still want to have deep strike, but try and preclude collateral damage. So what we've done is we've worked to product improve the Block 1 missile, and we have what we call the Block 1A.
What's the footprint of the submunitions as they explode? Football field, 2 football fields?
The effect of an individual submunition?
No,
of the collective
entire.
One ATACM missile.
I'll be very honest and I'll say that is classified. And it's classified simply because of the fact that if the enemy knows the capability, they know how to disperse the size of their enemy locations. In other words, if they have a unit that's, say, in a 400 by 400 area, and they know what the bursting radius or the capability of one missile is, their tactics could say, well, if they do 400 by 400, I'll do 800 by 800. So in other words, that's why we maintain some classification on what the terminal effects are and the capabilities of the warhead system.
There was a Lockheed representative here yesterday, and he was talking about the spread could be dialed up or dialed down.
That's exactly right. Yeah. We can adjust the burst pattern on these, and that's, I was reluctant to say that it has 3 pattern sizes, small, medium, and large. It sounds like you're buying a shirt almost, and I know you don't want to hear that. But basically, that's what you do. You do that based on the height of burst. So in other words, if you want to achieve a smaller pattern, you lower the height of burst, and this is done in the ballistic computer on board the launcher.
Let's go back to the baseball stadium again.
Yeah.
If we're firing at the baseball stadium over Baltimore, can we put a pattern just within the bases?
No.
It'd be too small. It'd
No.
be a little bigger than
Again, at a much greater range, you're covering the stadium.
that. You're still covering the stadium.
Yes.
You can't get smaller than that.
No.
Okay.
And again, remember, it's, if you take a look at the number of bomblets in this 950, and it, like I said, variable height dispense pattern, it's going to cover a large area. But again, it was designed to be an area fire weapon, deep strike area fire weapon.
Excuse me again, what did you say started the fires?
It's a pyrophoric pellet. If you take a look right in here, there's a little pellet in there that it ignites upon burst, And if it strikes or puts a hole in a gas tank or lands on ammunition, it has the capability of starting secondary fires and secondary effects.
How many submunitions?
In the Block 1 missile, there are 950.
You said at a much greater range you're targeting the stadium. Does that refer not just to the footprint of the weapon, but also the accuracy? I mean, you're not sure if you're going to hit the left field stands or whatever, or one of the parking lots even.
At the range out to 165 kilometers, we'll put it on the stadium. We will cover the stadium with the same, as I said, we would do at 32 kilometers with a rocket.
With the same kind of accuracy?
Yes.
Better accuracy.
Better accuracy.
Wouldn't there be better?
Again, because there is the free flight versus inertial guidance, if we wanted to aim for second base and say that's where we want the warhead event, but with the 950 submunitions, it would still cover the stadium. But yes, it is accurate to the target point, greatly increased over a free flight rocket.
Is this designed only for submunitions, or can it carry a high explosive warhead also?
There are other capabilities that need to be developed or can be developed for that. There are other generations or improved capabilities for the ATACMS missile that are currently in development and low-rate production, but specifically we're trying to cover those that are currently fielded and that are available to the force commander today. There are capabilities for unitary, but again, we have not established a firm requirement for that, but as the nature of conflict changes, again, we can expand to meet that type of requirement. Move on to the Block 1A missile. Again, we talked about the results of Desert Storm saying really need some extended range, need a greater reach. Range out to 300 kilometers, 180 miles. One thing I'll also point out about the difference between the Block 1 and the Block 1A, if you take a look at the system description, it talks about GPS-aided inertial guidance system. And to give you an idea of what that means in terms of accuracy, which I'm sure will be a follow-on question here, if you go out and buy a commercial GPS handheld system today, and you walk around and try and figure out what your location is, you can expect to achieve the same accuracy at 300 kilometers with the Block 1A missile. I can say that, and that's unclassified. So about its capability. You aim for second base at that range, you're going to have it come close to second base with GPS accuracy. You also point out that you notice that there's a fewer number of submunitions. Again, using the same fit, form, and function of the ATACMS missile to fit within the pod on the launcher, what we have done is we've extended the rocket motor, giving it the greater range capability, an improved guidance system, but because of the accuracy and the achieved range, only 300 of the M74 APAM submunitions, anti-personnel, anti-materiel. Like I said, this is currently a fielded capability within the Army.
Which is fielded with Task Force Hawk, Block 1 or Block 1A?
Both systems are fielded or currently available to Task Force Hawk. Again, the target set remains pretty much consistent for an area fire weapon. Soft targets, lightly armored vehicles, command and control sites, staging areas, deep sights. The advantage of this, again, is when you're going that deep into enemy territory, it provides the capability to attack under all weather conditions 24 hours a day. So that's one of the advantages, or that's one of the capabilities that it brings to the Joint Force Commander. We do not have the weather limitations that some other systems may have to face. Basically, that covers the major components of the MLRS system. I've talked about the launcher, talked about the rocket capability, and then the two versions of the ATACMS missile that are available to the force commanders today. At this point, I'd ask if there are any questions.
Colonel, given the problems you've had with collateral damage and civilians killed, could you give people assurances that the Block 1 especially, not the Block 1A, could be used with to destroy Serb forces without causing collateral damage to civilians?
Well, I will not talk specifically to how it would be employed or what they would target in this current endeavor. What I can say is, in our tactics, techniques, and procedures, we look at the nature of the target itself, and then you take what's surrounding that target. Where we pick the aim point for that munition, in other words, where it hits or explodes in relation to the target area, you still want to achieve effects on the target, but yet by how you aim it and where you want it to explode, you have the ability to try and limit, in some sort, the collateral damage to other structures based on that. But again, it's an area fire weapon system designed to cover massed forces, large target areas.
What's the minimum range on the 1 and the 1A?
The minimum range on the Block 1 is 65 kilometers, and the Block 1A is 70 kilometers.
So that's when you get the trajectory depressed as low as you can, and
Actually,
whatever.
it's still high, but it's just the shorter burn the way it comes down, right? From apogee and then where it brings it in.
Colonel, could you talk about how the system coordinates with the Apaches, how they operate?
Sure. Okay, that's a very good question. Basically, in our techniques, I believe a couple weeks ago you had Mike Hackerson talk about the Apache system and some of its capabilities. At the divisional level as well as at the corps level, we work very closely, not only with the Apaches, but with the Air Force systems, their sensor systems as well as their attack systems. So basically, if we use, say we're going into an engagement area or a kill box, and the kill box is going to be also attacked by, say, Apache helicopters, as well as Air Force aircraft, what the ATACMS can provide the commander is, number one, it can provide the suppression of enemy air defense. So it provides that if we know, based on our intelligence and sensor platforms, find out that there are air defense capabilities that are a threat not only to rotary wing, but to the jets, we can use the ATACMS missile to strike those and take them out to allow greater freedom of movement of attack aircraft once in the target area. We do that by just coordination of mission timings. We know where the air routes are. We do the timing to make sure that the arrival of the aircraft and the arrival of the missile are not coincidental. So this is part of our training, and this is how we work it. Again, the communications, the digital fire planning that is done up front. And in this case, that would be an example of a pre-planned mission or a coordinated attack using Apaches as well as the Air Force aircraft. Yes, sir.
How dynamic can you be in terms of the Apaches saw something they wanted taken out and communicated that to their Blackhawks? Could they communicate to you where to attack, or is that in a cluttered airspace as we have over there, is that too risky?
No. Matter of fact, that's a mission that we routinely train for. It's called an immediate mission. The Apache goes out there and, say, with its laser capability, it finds an air defense target or another target that it sees as a threat. Digitally, he could send the target coordinates back through the Deep Operations Coordination Cell and enter the Army's, or the Artillery's fire control system, the Army Field Artillery Tactical Data System, and that mission can be sent down to the MLRS launcher. So you have the responsiveness through digital communications to do that, and again, it's the time of flight of the missile to engage that target that the Apache probably has designated for us.
Can you expand on it just a little bit? I mean, let's say you've got a target 150 kilometers out. What's the time on target from the time that MLRS crew gets the word to fire on a target? How long does it take?
Time of flight out to 150 kilometers, we'll say about 3.5 minutes.
How long does it take?
And then you do with command and control time. We routinely shoot for mission response times on a pre-planned mission of less than 8 minutes to include time of flight. And we'll say out to that range because the longer range, greater time of flight expands your total mission time.
You say a pre-planned.
In this case, like if we were going out in a suppression of enemy air defense, we know where the target is. He would be standing by ready to fire the missile. All we know is when the order is given it, then it's time of flight to hit that target.
Let's say an Apache's there and it sees a column of SERB or someone else's vehicles coming along, clearly identifies them as military. Can it get a rapid enough response to go after a column that might be moving at a fairly slow rate of speed?
Let me say first that the ATACMS missile is not designed to hit moving armored formations, not one of the target sets that we'd shoot at. But let's turn that around and say that he picks up a threat warning of an air defense radar that is trying to pick him up or trying to track him. If he can locate, and other platforms, intelligence platforms, can locate that radar, send down a location. If you take communications time as well as command time, yes, we want to engage that target with an ATACMS missile. That's the variable that we train toward. That's the tactics, techniques, and procedures. The standard that we have to deal with is the actual flight time. If you talk about an environment that we're in today where people are focused on that, if it is a cross-FLOT mission across the friendly line of troops into enemy territory, obviously the chain of command is keyed and prepared to react to this type of mission. The units are standing by with the capability. All they need is the target coordinates and the permission to fire. It can be very slow if it were in a very expanded environment, or if we're focused as we are in this situation, it could be very small. And like I said, it could go 10 minutes, it could go 2 minutes to make that decision, plus the time of flight and the responsiveness of the launcher.
Colonel, I take it that these, you mentioned that these ATACMS can be used in support of fixed-wing aircraft as well as rotary. I take it that has not yet happened in Kosovo. Am I right? And if not, is there any discussion? Have arrangements been made for these pieces of equipment to be used in support of the Air Force?
I can't answer the specifics of what the commander on the ground is going to do over there, as well as what the NATO chain of command and our National Command Authority will authorize to be used over there. But I can tell you routinely in training, based on the deep strike capability out to a range of 300 kilometers, if an Air Force is coming in a high-threat environment and we could fire an ATACMS missile at, say, an air defense or a command and control site, and that's impeding his flight onto that target, we routinely train to accomplish those missions in support of the Air Force. The timing as well as the range and the precision that we want to engage it with.
You are able to say that it hasn't happened yet in Kosovo?
To the best of my knowledge, no, it has not.
Excuse me, Colonel, you wouldn't use these against man-pads, would you? I mean, it's like killing an ant with a sledgehammer kind of, isn't it?
That's a good way to describe it. Again, you have to take a look at what the tactical commander's decision on the ground is. If you take a look at what's available, what the tactical situation is, what he is trying to achieve, it's another tool in his toolkit that he has. He says, is it the most appropriate one? Maybe not, but if it's the only one he has, he may make the decision to employ that type of system.
But would would it be an appropriate answer, given that like the SA-7s that the Serbs have are easily, I mean, they're moving around, they're not fixed targets like you were describing. That's not normally the answer, is it?
It would be
like that?
Targeting a man-pad system is very difficult. There's no question about it. It has the tactical mobility, and it's very hard to pick up unless he's actively engaging. Does the commander decide to use this system against it? Again, it's a tactical judgment by the man on the scene. Yes.
The supplemental package of the emergency supplemental on the Hill, is there anything in it for MLRS or ATACMS for you guys to either accelerate, buy more of? What?
Yes, there is. The ATACMS, Block 1A was specifically mentioned in the supplemental package that's up on the Hill. Yeah, in other words, what they're trying to do is we entered full rate production on the Block 1A ATACMS capability, and we have, based on yearly budgets, the number of missiles that we're going to procure. What this will simply do is accelerate the number of missiles that can be built by Lockheed Martin Vought Systems on an annual basis. Yes.
NATO's already conducted like 56 days of airstrikes. I don't understand what the ATACMS bring to this fight. If these ATACMS are aimed at fixed targets already, it seems to me that if they would pose any threat to Allied forces, that we would have already taken them out with airstrikes. So I mean, unless they're meant to operate independently of any Task Force Hawk operations, I don't understand what protection they bring to the Apaches.
If the Apaches were employed in that type of operation. What they do is provide the quick responsive fires when the Apache is in a hostile environment. That's the added dimension that it has. The Apache goes out there to look for and engage targets in a pre-selected engagement area. If he encounters hostile threats en route, either he deviates from his mission to deal with that threat or avoid that threat, but he still has his primary mission of engaging the targets out there in the kill box or engagement area. The ATACMS provides the immediate responsive fires at an extended range that the Apaches can operate to service that target, so to speak, so that he can continue on with his mission. It also should, we can use the Apaches to engage that target area prior to the Apaches arriving. If the nature of the target is such that he's going in there to take it out, the missile arrives, executes, again, hopefully eliminating some of the threat, and the Apache just cleans up the pieces after that, so to speak. It's a complementary effect, and you look for, in a combined environment, multiple weapon systems designed to achieve a specific objective. What is the synergy that bringing these all together provides? And that's what the tactical commander takes a look at.
So your presumption is that there are a certain number of targets that NATO has not even located yet, but that Apaches may come across at a lower altitude, or simply SERB forces that reveal themselves by opening fire, and that the usefulness of this thing is then. I mean, is that basically what you're saying?
I'd say that's a high probability, and that's what we routinely train for, that type of environment.
The range you fire, even the MLRS, wind obviously is a factor. How does your your fire control computer take into consideration the weather conditions, winds, and where do you get your feed, your meteorological data?
Associated with field artillery units, there are what we call meteorological stations, MET stations, and they provide wind data, air density, temperatures all throughout the entire spectrum of altitude. And it's a ballistic computation. It's fed into the computer, goes into the onboard fire control computer where it accounts for that in its selection of its aim point.
Do you normally fire one?
Rocket or missile?
ATACMS.
Okay. In the ATACMS environment, again, depends on the size of the target. Routinely, when we do this in training, we look at firing 2 missiles, and again, to achieve the effects. You can select different aim points, and it depends on the size of the target area itself. While one missile may go against a specific part of the target, we may choose an aim point for another missile at another component or element of the same target set.
To rephrase a previous question, could ATACMS substitute for some of the munitions dropped by the fixed-wing aircraft?
If it falls within the appropriate target sets, if they are going after air defense sites, logistic sites that can be engaged by the AP ammunition, the answer would be yes.
So there is some overlapping capabilities
Yes.
there. What does an ATACMS Block 1A cost?
The production cost for a Block 1A is about $900,000 per missile.
And lastly, can the launcher fire on the move?
No, it cannot. But I'll talk about emplacement time. We use what we call mission cycle times. From the time that the firing crew receives warning that you need to go fire a rocket or a missile until the time that is completed. So he moves from a hide position up to a pre-selected firing position, execute the fire mission, and retreats. Our goal is less than 10 minutes to accomplish that entire mission cycle and be out of the area, because that aids his survivability.
How many batteries are in Albania?
Right now, there are currently deployed with Task Force Hawk 2 batteries that came from 5th Corps, and there was IPDS launchers that were deployed from CONUS to support them. The Improved Position Determining System Launcher. A platoon of those came from Fort Sill, Oklahoma.
How many launchers is that?
Uh,
Sorry.
I believe there are in excess of 15 to 18 launchers there at this time. Again, it's the best hand knowledge I have right now.
While you're on, before you go too far away from cost, what's the cost for the other missiles with less range?
The Block 1 missile?
There's the Block 1 and then the first one that you mentioned.
MLRS.
Okay.
MLRS,
The Block 1 missile cost is about $645,000. And if you go back to the procurement of the basic M26 rocket, we took a look at a cost of those for a rocket pod of 6 rockets was about $29,000, and again procured back in the 80s and stockpiled today.
If the man-pads are the main threat to the Apache, how else do you deal with that if not with these systems?
You mean an air defense threat against like an Apache aircraft or other aircraft?
Yeah, using a man-pads. I mean, they say there's thousands of man-pads, and that's one of the main threats to the Apache are these man-pads. But you seem to be saying that these artillery are not really suited for that type of threat.
Well, if it's a fleeting target, if you have a single man with a shoulder-fired air defense missile, the commander has to weigh and said, is that, can the Apaches or other aircraft avoid that once it's detected? Or do they use other jamming capabilities aboard the aircraft or other sensors that are up there jamming capabilities? Or do you employ other systems that have the range to engage? Again, it's a very dynamic situation. When we say air defense sites, we're talking larger like the SA-2, SA-3 missiles that have fixed air defense radar sites. In other words, there's a network of radars as well as surface-to-air missiles. Those are the larger target sets that ATACMS was primarily designed to engage.
But you're saying, just so we understand, you're saying that these missiles probably cannot do much to prepare the ground before the Apaches go out to begin with. I mean, much more that's already been done by the air campaign.
Again, if we wanted to just do saturation effects on an area, yes, that the APAM and ATACMS missile is capable of doing that, but in this environment, we're trying to limit collateral damage, going towards more precision engagement. I'm not really sure that the tactical commander would do that.
But I guess, is there something that can be done to prepare the ground more than has already been done for the Apaches, or do they face a situation of having to go out on the first day and put themselves at risk in order to flush out targets?
Anytime you go into enemy territory in any type of aircraft, you put yourself at risk. What ATACMS provides and the MLRS deep strike capability is that you can engage targets at great depth without putting an aircraft or a pilot at risk. Deep strike without putting a pilot at risk to engage the appropriate target set.
Colonel, these are obviously devastating weapons. The 1A, would you describe what would happen to whatever's within a 50-yard radius the way that would go off? What these pellets would do? Would it shred the trees, shred everything? Kill
Yes.
everything, everybody within a 50-yard radius? What would it do?
It's pretty devastating. Matter of fact, the PAO office has some file footage of what the APAM bomblet looks like on a missile warhead event. That's how it got the nickname Steel Rain, because of the density of titanium fragments from the exploding submunition. It covers a very, very extensive range, very dense, and therefore very capable and very effective.
And if you are at the target area there, you don't know that this is coming. You don't hear anything, do you? Or do you? If you say I am at ground zero where this thing is coming in, you've launched it from well out of visual range. I haven't heard anything. Have I seen a missile? Have I seen a rocket plume?
There is absolutely no warning.
There's nothing.
You don't hear anything. It's a supersonic missile.
Okay.
It's coming in at a very steep angle, very high speed.
So the sound arrives after it
That's
hits
right.
me.
And at that point in time, I don't think he's going to hear the sound of the missile itself. He's
So
going to be
just
worried
know
about
clear
his own
blue
self-protection.
sky, clear
Right.
blue sky.
And that's one of the advantages that this system provides. I mean, you can't hear it coming. It has a very low radar cross-section, so it's hard to detect. And at that range, you know, what does the enemy feel? How threatened does he feel at that time? So that's a new dynamic that the enemy says they have this system capability, deep strike, can't hear it coming, don't know when it's going to be employed, don't know where it's going to be employed. So that forces the enemy either off his timetable or causes him to move his troops or to have another consideration of when he moves them, how safe am I when I do that?
Colonel, you talked about the overlap in capabilities.
Yes, ma'am.
And is it possible that the MLRS would prevent the need for the Apaches? And also, I think you indicated that it hasn't been used yet. Why hasn't it?
Again, I'll address first why it hasn't been used, or it hasn't been used that I'm aware of to date. Again, those are decisions not only that the tactical commander has to make, but they're also political decisions through the NATO as well as through our National Command Authority. It'd be unfair for me to even estimate or guess when such a system would be done or what the need would arise that would cause the Joint Force Commander to say, I need it, and it gets approved, beyond the scope of that. We take a look at the synergistic effect of weapons capabilities. Apache is a very, very capable and effective system, did extremely well in the Gulf War, has demonstrated its capability. The same could conversely be said of the ATACMS. But when you put that capability together and strike an engagement area where they don't know it's coming, you hit an element or part of that target set, and then you have the Apaches come in and provide that same type of kill capability against remaining targets or other targets within that engagement area. It's a synergistic effect, again, mass lethality, mass effects at a deep range, and that's what the two systems together can provide.
Both.
Yeah. Yes.
Just to go back to what we talked about earlier, other variants that are in the works. Is there an armor variant, say sensor fuse, something like that, in the works? And
There is,
also,
yes.
And you also mentioned a unitary warhead, since it's supersonic. It could be a penetrator, I assume. Do you have any timetable on when those are?
I'll address the first one. We have what's just entered. We received DoD approval to go into low-rate initial production of what we call the ATACMS BAT, Brilliant Anti-Armor Submunition capability. What that capability has, it's a ATACMS missile that has 13 submunitions, gliding submunitions that have the capability to hear as well as sense moving armored combat vehicles and engage them. Again, it's in low-rate initial production. It's not in the field at this time. As far as their other variants, along with the developer and the Army scientists, we look at other capabilities based on targeting requirements. If there is a need for a unitary capability, I've already told Lockheed Martin has done work on that. They find that that is a very easy modification to make to this system, and it's a question of, does the Army have a requirement to do that? Yes.
Is there a significant dud rate for the submunitions? And if these submunitions are do fail to fire, do they lie on the ground waiting for someone to step on them or a vehicle to strike them?
That was a comment that did result from the Gulf War. With the on the ATACMS missile, the M74 bomblet has an unclassified, I'll say, less than 2% dud rate. So if you do the math, say of 300 submunitions, less than 2% of that, it has not been a significant problem with the ATACMS munition or submunition. But again, it's a concern. And if you had civilians moving through the area afterwards, that's why one of the things in this environment, one of the considerations that the tactical commander has to use before he decides if, when, and where to employ the system.
Some of the airdrop cluster bombs, I gather, are now being manufactured with timers inside the
Right.
subunits. Is the same deal with this?
This does not operate on a timer. What this has, actually, it's a spinning arming mechanism, anywhere between 2,500 and 3,400 RPMs. This thing turns at, that arms the submunition, and when it hits a surface, that's when it explodes. There are munitions that are being developed, what they call a self-destruct fuse capability. That was not designed into this because of the low dud rate, and there was not a requirement for it when these went into production.
I may have the wrong system, but in the Navy also looking at this for various purposes?
Yes. You're talking about the ATACMS?
Yes.
Yes. The Navy has looked at it. I've worked with the Program Manager's Office for ATACMS, collectively with us and the Navy, at looking at a Navy TACMS variant. It's again a question of what the Navy is looking at. There's also another system, the Standard Land Attack Missile System, that the Navy is looking at, and I understand there's some debate over that.
A question on what MLRS crews do what kind of training. You said some of them, I guess the 2/3 of them come from Europe and 1/3 comes from your place. Is that
No.
right? No. Let me just ask the whole question.
Sure.
And the whole question is, I'm wondering whether MLRS crews routinely train for this sort of peculiar specialized mission of supporting Apaches and not having ground forces around you, and whether, for instance, these ones from 5th Corps would have done that, or whether it would just be the people from Fort Sill that would have done it.
And that's I think it is strengthened advantage of the system itself. The 13 Mike, that's the MOS for the MLRS crewman. He trains the same whether he's in 5th Corps in Germany or CONUS based. He has the same type of mission. He has the same launcher. And really, whether he's firing a rocket or a missile, the crewman goes through the same procedures within the cab of the MLRS launcher. So in other words, they routinely train for the pre-planned mission, say the suppression of enemy air defense mission. And he's capable of doing it within his prescribed timelines to execute that mission.
I'm a little puzzled. I guess it might just be when they brought up an MLS for us a couple of weeks ago. They had it parked outside. I think it was manned by reservists or National Guard.
No, actually, it was the unit, the 3rd of the 27th Field Artillery out of Fort Bragg, North Carolina.
Well, I asked these guys whether they'd ever practiced doing something in support of the Apache, and they said no.
That's the crewman. When he is firing a rocket or a missile, he has no idea what he's supporting. Okay. But in the fire support, in the fire control structure, to the crewman, it's the same mission, whether it's maneuver forces that he's supporting or supporting a deep strike with Apache aircraft. His procedures are the same, and that's the good part about it. It's the senior commanders and decision makers and fire supporters that work the integration and command and control piece.
Colonel, one last question.
Yes, ma'am.
You called this a direct combat system. I know the Defense Advisory Committee for Women in the Services has tried for years to get women soldiers to work with the MLRS. I believe they claim it's not a direct combat ground system. Do you know where that difference of opinion lies?
Not my area of expertise, but if you take a look at how the system was employed, again, employed in a combat environment, we routinely train where it moves with the Bradleys and M1s. So in other words, our infantry and armor forces. And during the Gulf War, there were many incidents in which the MLRS was employed in front of the Bradleys and the Abrams tanks to engage deep. So, yeah, it's definitely a direct combat system. The fallout of that as far as women and the MOS within the field artillery, really, that's not my area of expertise, man.
Colonel, maybe one final one. Well, you've got 20, you've got 25 years in this business. Would you say that given the terrain and given the fact that the Serbs have used human shields, would you say that the chances would be likely to be greater for collateral damage using these across the border into Kosovo than they were against desert targets in the Gulf War when you were chiefly firing at troop concentrations or troops and artillery?
I think that's one of the commander's tactical decisions that he has to make. It's a very tough environment. Again, it's an area fire weapon system. And the question is, what are the tactics as well as the politics of the time that dictate what is the best system to employ to achieve, the decisive victory that we say we're going to achieve there?